Welcome to this explainer. Today, we are absolutely diving into the deep end to break down some massive news about OpenAI's brand new computer chip. We're pulling all these details directly from recent industry reports. Look, if you've been following the AI space at all, you already know that the hardware running these massive models is literally the single most expensive, most fought-over territory in tech right now. So we're going to map out exactly what OpenAI is building, why they're doing it, and honestly, what it means for the future of the tools we use every single day. Okay, so let's start with a really relatable frustration. Why is ChatGPT suddenly getting so slow? If you've noticed your prompts taking a little longer to generate a response recently, well, you're definitely not alone. And no, the technology isn't going backward. It's actually because the models are trying to be smarter. But to really wrap our heads around the hardware solution OpenAI just announced, we've got to first define the software problem that's kind of bottlenecking everything right now.
Which brings us to Section 1, the AI thought tax.
Let's look at what's actually happening under the hood when you hit enter. Every time the AI stops to reason deeply or, do complex math, the time it takes to generate your very first word naturally takes a huge hit. The newest generation of thinking models doesn't just spit out the first word that comes to mind anymore. They generate thousands of hidden reasoning tokens first. It's basically a hidden chain of thought tax. And when you have multiple AI agents working together on a complex task, all reasoning at the exact same time, you get what's called compounding agentic latency. It just makes things slower and slower and slower.
And this perfectly illustrates the dilemma OpenAI is facing right now. Currently, you kind of have to choose between speed and intelligence. On one hand, you've got the lightweight flash tiers. They're blazingly fast, but they just don't have that deep, methodical reasoning. Then, on the other hand, you have the flagship models. They do the heavy intellectual lifting, but man, they are incredibly slow to deliver that first token. It's a massive bottleneck because what you and I actually want and what the whole future of AI demands is flagship intelligence at flash speeds.
All right, moving into Section 2, meet the Jalapeno chip.
To solve this exact bottleneck, OpenAI made a huge announcement with Broadcom, doing something they have literally never done before, designing their own silicon. Working samples of this highly efficient processor, codenamed Jalapeno, have already been handed directly to OpenAI's leadership by Broadcom's CEO. This is a massive, massive pivot away from relying solely on third-party suppliers like Nvidia. OpenAI basically realized that to get the performance they desperately need, they have to own the physical brain running their software.
Now, the sheer speed of execution here is what's truly staggering. 9 months. It took just 9 months to go from the very first design all the way to manufacturing tape-out. And if you're not familiar, tape-out is the industry term for when a chip's design is completely finalized and sent off to the factory to be physically manufactured. In the world of advanced semiconductor manufacturing, 9 months isn't just fast, it's virtually unheard of.
And hey, you don't just have to take OpenAI's word for it. When Broadcom, your massive silicon engineering partner, calls it possibly the fastest development cycle ever, it really puts into perspective how aggressively OpenAI is moving. They aren't treating this as a fun little side project. They are treating it as an absolute mission-critical sprint. Which leads us to Section 3, built purely for inference. So how does Jalapeno actually fix the speed problem we were just talking about? Well, every time you type a prompt, that process is running on what's called inference. Inference is the heavy lifting of actually generating the answer back to you, and Jalapeno is designed from the atomic level up to make this exact step cheaper and way faster. It is not designed to train the model, it's built entirely to serve the model to you, the user. And here's why that distinction is a total game changer. General-purpose GPUs, like the incredible ones Nvidia makes, are essentially the Swiss Army knives of chips. They are fantastic at everything, including the ridiculously demanding job of training AI from scratch. But being good at everything means they aren't perfectly optimized for one single task. Jalapeno, though, it's an ASIC, an application-specific integrated circuit. By stripping out literally everything that doesn't help with inference, this custom chip can run much closer to its theoretical maximum speed. It moves way less data around and wastes significantly less electricity.
When hardware is custom-built for AI inference, the leap in speed is just mind-bending. Check this out. A standard GPU outputs about 66 tokens per second. But recent industry demos on custom inference setups, they push a staggering 2,500 tokens per second. Jumping to that kind of speed could eliminate that thought tax entirely. Imagine thousands of AI agents reasoning and acting for you in real time at that speed. It completely rewrites what is possible.
Okay, Section 4. Designed by AI. For AI. Honestly, this is the craziest detail from all the source material. The very AI models that OpenAI serves up to users every day are now actively helping to build the hardware that will run future AI. They literally put their own software to work to speed up the optimization and layout of the Jalapeno chip itself. Talk about an incredible feedback loop. If AI can genuinely help human engineers design better chips more quickly, that has the potential to permanently lower the barrier and the cost of building advanced hardware across the entire tech industry.
But they certainly didn't do it alone. Pulling this off requires a massive orchestration of the world's biggest tech manufacturers. Think of it like a relay race. First, OpenAI designs the core architecture. Then, Broadcom steps in to handle the highly complex silicon engineering and networking, using their Tomahawk technology to let thousands of these processors talk to each other. After that, TSMC over in Taiwan actually physically manufactures the microscopic transistors. And finally, Celestica takes these finished chips and builds the physical server racks to house them. It's just a masterclass in strategic global partnerships.
And finally, Section 5. A fight for survival.
So why is OpenAI going to such extreme lengths to build this entire hardware and software stack from scratch? Well, according to the reports, controlling every single layer, from the models to the software down to the physical hardware, could lead to a 50% lower cost compared to typical setups. And that is absolutely vital because right now, current AI subscriptions are heavily subsidized. Let me be totally clear here. Running large language models today is incredibly expensive. If they don't find a way to radically cut the costs of inference, the current business model simply won't survive at a global scale. So this chip, it's as much about financial survival as it is about technological speed.
And Jalapeno is really just the opening move. It's part of a massive multi-generation plan aimed at total hardware independence. The first of these servers are expected to come online by late 2026. But looking a bit further ahead to 2029, OpenAI, alongside partners like Microsoft and Broadcom, is aiming for what they call a gigawatt-scale deployment. We are literally talking about 10 gigawatts of custom AI chips deployed across massive new data centers. The scale is almost hard to comprehend.
Which brings us to our final thought. If AI is now actively helping to design the faster, cheaper hardware that will in turn train and run even smarter AI, where exactly does the loop end? I'm going to leave you to ponder that one, because it's crystal clear that the race for AI supremacy has permanently moved from the software into the silicon itself. Thank you so much for joining me for this explainer. Keep your eyes on the hardware, folks, because that is where the future is actually being built.